In studying uniform accelerated motion, common piece of equipment that we use is the picket fence, so named because it vaguely resembles a picket fence. This is a standard piece of equipment used in many cases, and when you tell the computer you're using a picket fence, it knows pretty much what you want to do because no one does anything but this experiment with this that I know of. The picket fence is made of an acrylic bar with 5 centimeters spaced intervals of dark. Now, what happens is you tell the computer using a picket fence, and it's going to measure the time between each one of those. So you drop the picket fence in the photo gate, and then as it's falling, then the computer will measure the time between each of the markings. And so as you measure the time between each of the markings, then this is the information that's used in order to figure out the acceleration and the velocity at various times. Now, what happens is that the computer starts timing as soon as you click start, and then it will trigger the photo gate once it has fallen to this point right there. And so then the next time it triggers the photo gate is when it falls to that point. Next time is when it falls to that point. Next time when it falls to this point. Next time to this point. And so what's going to happen is the computer is going to record this T1 when that is first blocked, T2 when that's blocked, T3 when that is blocked, T4 when that is blocked, T5 when that one's blocked. And then it's going to say, well, this distance right here is 0. That's 5 centimeters, 10 centimeters, 15 centimeters. So that'd be 15 centimeters. So 15 centimeters, 20 centimeters. And then you can graph that x versus t. So x and then t. And what will happen is that's going to give you a parabola. Now the t, however, is going to be the time since the time that you started, not the time it started falling. So what will happen is the parabola will look something like that. So it'll be a little bit off-centered. Now, that's the basic idea. So this gives you the x1, x2, x3, x4, x5. Okay. Now, to find the velocities, v1 is going to be the velocity when you do x2 minus x1 divided by t2 minus t1. Now, x1 is going to be 0 because at the first time it hadn't fallen anywhere. And then v2 is going to be x3 minus x2 divided by t3 minus t2. Then v3 is going to be x4 minus x3 divided by t4 minus t3. Now, each of these is the average velocity. So the average velocity going here is going to be v1. The average velocity there is v2. The average velocity there is v3. Now remember, this is x1 at t1. That's x2 at t2. This is x3 at t3. This is x4 at t4. Well, when is it the average velocity? It's going to be initial velocity right here. It's going to be another velocity here. So v1 comes at the midway point between t1 and t2. So v1 occurs at some time t1 prime. v2 occurs at some time t2 prime. V3 occurs at some time through T3 prime. Well, how do you get the T1 prime? T1 prime is midway, sorry, it doesn't look right. So T1 prime is midway between the initial T1 and T2. So that's going to be T2 plus T1 divided by 2. T2 prime is going to be midway between T2 and T3. So that's going to be equal to T3 plus T2 divided by 2. Now again, if we have constant acceleration, which is what we're assuming here, because gravity is constant acceleration, that's what's making it fall, then the midway time is going to be the average of those times. So T3 prime is going to be T4 minus T3 divided by 2. So T4 plus T3 divided by 2. So that's going to be midway between T3 and T4. So now you have established, a new data table with velocities at certain times. If you were to make a graph of that, velocity versus time, then what happens is that's going to come out as a graph that looks something like that. Now, it's going to have an initial velocity because the picket fence, as it was falling, by the time it reached the photo gate here, it already was moving, so it already has an initial velocity. So that means that it's not going to go through the origin. Now, the lab wants you to find acceleration. So to find acceleration, what you've got is you've got V1 at T1 prime, you've got V2 at T2 prime, you've got V3 at T3 prime, you've got V4 at T4 prime. So how do you find acceleration? Well, average acceleration is change in velocity over time. So what you would do is you would say, using that information from the calculations you've done before for V and T, then you would say that A1 is going to be equal to V2 minus V1 divided by T2 prime minus T1 prime. A2 is going to be V3 minus V2 divided by T3 prime minus T1 prime. Likewise, A3, you can figure out what that's going to be. Now, we have these different A's, but these are all average A's. So it's not going to, the acceleration is not going to be at the beginning of the time interval at T1. It's not going to be at T2. It's going to be at some point in between. So you're going to come up with these A1, A2, A3s. They're going to be at some T1 double prime, T2 double prime, T3 double prime. So we're going to build this data table. So how do we get these time double primes? Well, T1 double prime is going to be midway between T2 prime and T1 prime. Likewise, T2 double prime is going to be midway between T3 prime and T2 prime. Because we've got constant acceleration, the midway time is going to be the average of those previous times. So if you make a graph, so a graph if you were to graph acceleration versus time, now the time is going to be the T double primes, and you'll get a graph that looks something like this, where you have the average accelerations. it should make a horizontal line that averages out about 9.8 meter per second squared, but that's the ideal. And so this is how the picket fence works to use the computer to measure the acceleration due to gravity. The picket fence used with the photogate turns out to be one of the best ways of measuring the acceleration due to gravity, and that is primarily because using the picket fence, then as the as it falls through the photogate, it does not matter if the initial velocity is zero or not. In the previous methods we used, we assumed the initial velocity was zero, and that actually was a source of error. There's also very little reaction time. The computer doesn't have much reaction time in there, and it uses the difference in position and difference in time to measure the average accelerations, and difference in average acceleration over difference in time gives you acceleration. And it even computes when it is expected to be at those different times for acceleration and velocity. It doesn't just use the initial times, so it recomputes that. So that's the power of this as a system of measuring the acceleration due to gravity.